Hi and welcome to this video about showing what Windows does at boot with a tool called Process Monitor. So Process Monitor is a fairly well-known tool from the sysinternals suite of tools, and in fact in some point in time Microsoft created, someone at least at Microsoft created this kind of t-shirt. If you have something crazy going on in your machine, don't panic. Run Process Monitor and you'll be able to figure out what is going on. So what I want to do in this particular video is show you just some aspects of Process Monitor that are related to looking at what happens when booting Windows. So it's not going to be a video about everything Process Monitor knows how to do. It's something that I might decide to tackle in a future video, but I do want to show you how you can see what is going on when Windows boots up. So first thing I'm going to do is launch Process Monitor. And you notice it requires elevation. The reason for that is that when you try to capture something, it uses a driver. So you can see that Process Monitor has a bunch of things it can capture. You can see them here in these 4 or 5 buttons. We have things related to registry activity, file system activity, network activity, and process and thread activity. There's also some stuff related to profiling events, which I'm not going to cover in this video. And so the main way that Process Monitor works is by using a kernel driver. It has a kernel driver that monitors registry activity. It has the driver also monitors file system activity as a file system mini filter, and it also monitors process and thread creation destruction. Same goes with loading of modules. But then there's also network, and networking is the only thing that it does using event tracing for Windows, or ETW, rather than having a kernel driver for this purpose. So having a kernel driver is very powerful, because then when you double click to see a particular kind of event, you can see exactly what is going on, the actual operation that happened, the process under which context this actually happened, and also you can see the full call stack of the operation. So if you give it a little bit of time to perhaps show proper symbols, then you'll see that we get exactly what happens from the location where this registry operation in this case occurred. This thing right here, we talked about some reg query key here, and you can see that it actually, top of the stack is a callback coming from the configuration manager. That's the CMP here, configuration manager private. That's the component used in the kernel to manage the registry. And so you can see this is really coming from a callback provided by the kernel that the driver registers for. So anti-query key is the native API in user space, and so on, and some part of Explorer is calling this function, which is not very interesting for our purposes too much here. In any case, you have some great information you can get for each one of these events. So that's one thing we can see here. We can filter things out. So for example, if I don't care about a registry operation, I can just uncheck this particular button, and then the filtering will just show everything else except for these registry activities. Now we can see file system activity stuff here, and even process and thread stuff that is happening. And notice it continues to capture this information because we're currently capturing events using this capture button, or you can see that in the ability, the basic thing here to capture event. You can see there's a Control-E shortcut for that. So you can filter that out as well. We can filter this thing out. It will remove that, and now we'll see the other stuff like processes being created and destroyed, network activity, things like that, that Process Explorer knows how to provide. We can be even more specific than that. For example, maybe we only care about things related to this SVC host executable. Only SVC host, we can right click and then do something like include SVC host, and this will filter out so that we see only SVC host processes. We're not going to see any Explorer, anything like that. So we can really dig into what we want to get. Now, before I show you how to log boot operations, I want to mention one more thing from a configuration perspective. If you go to options and select here the option to configure symbols, you should be able to do that. And it's important you do that if you want to get good call stacks. If you don't care about call stacks, then that doesn't matter. So the symbol path is the usual one to the Microsoft symbol server. And if you have the _NT symbol path environment variable set up, it will pick that up automatically. However, to actually get proper symbols, you need to point dbg help to the file that's provided by the debugger tools for Windows installation and not the one provided by the System32 directory. If you're familiar with Process Explorer, this is exactly the same setting you have to provide there in order to get proper symbols. So once you have that, let's say we want to see what's going on at boot time. This is something that many people don't know that Process Monitor actually supports. So if we go to options, there's an option here called enable boot logging. And I'm doing this in a virtual machine because I want to continue recording. But you can do that, of course, on a physical or non-physical machine. So you can see we can just say that we need to enable that. We can also generate profiling events, which I'm not going to do here to reduce the amount of data that we get. And I'm going to click OK. So now the only thing we have to do is simply to restart the system. And what happens here is that the Process Monitor driver is being configured to start as a boot driver. That is very early in the Windows boot. And that's what allows this to capture things when things just get started. So I'm going to do a restart here and let the machine restart. Since it might take a couple of minutes maybe, there's also some overhead based on the information that's going to be gathered by Process Monitor. I'm going to pause this video and wait until the machine boots up. Okay, so the virtual machine has booted up. It's coming up, and hopefully if everything went well, then Process Monitor has gathered information, and now we should be able to get to that information by running Process Monitor again and accessing the information that it gathered using a file that was used to capture all those details, all the events that happened from the time the system booted. Let's give it a couple of more seconds, a few more seconds to actually launch things. So probably this kind of slowness might be acceptable because we are running on a virtual machine that doesn't have too many resources, and the Process Monitor driver continues to aggregate information as part of what we're trying to do here. Okay, so now we can try to launch it. Even though Explorer is still not properly up, Process Monitor seems to be in a good enough shape. Let's just run this, see what we get. So I've launched it, but again, it might take a few more seconds for everything to settle down. Explorer itself, the taskbar, you can see, is not yet properly visible on this Windows 11 VM. Here goes, we're launching ProcMon. A few more seconds. So here goes. So the first thing we see is that the Process Monitor filter dialog pops up, and that's because we did something like only look at SVC host processes, things like that. So we want to remove that perhaps, and I'll talk about the filter momentarily. Let's just remove that single thing and click OK. And you can see that because we did boot logging, we get this message from Process Monitor that says, hey, apparently there's some information there about boot time activity. Do you want to see that now? I'm going to say yes. It's going to suggest to me to save it somewhere. We have to save it. So let's save it using this default file name bootlog.pml. PML is the ProcMon log, the internal format used by Process Monitor. And now it's going to save that and process those events. And by the way, the file you're going to get is going to be a pretty big one. It might be several gigabytes in size. So much is happening when Windows boots up. So it might take some time here to process these events. You can see it tries to give me an estimate, and that estimate is not very accurate because it is faster than it looks. So let's give it a few more seconds to finish that kind of processing and see what we get. So obviously we're not going to do any live capturing now because we're looking at an existing log that has already been captured by ProcMon's driver while Windows was booting up. And here we go. We see a normal output from Process Monitor, and you can see that the acquire or the capture event is not enabled because we're not capturing new events. We're just going to look at this static picture of what happened from the moment Windows booted up. But all the other options are available. So we can, for example, bring back registry activity or file system activity. You might notice we don't actually see anything, which seems a bit weird. I mean, doesn't SMSS do any kind of registry activity? Well, it does. Why don't we see that? That's because I have an option that is called here, something that I probably should have changed. It's called drop filtered events. That's not the default, but that's what happened when we set the boot logging. Process Monitor was looking at the current options, and the current options said don't capture file system registry activity, and that's why we see nothing of the sort. So we actually have to do this thing again to recapture and have everything enabled here. Otherwise, we're going to miss a big chunk of events that you might be interested in. Maybe you're not. If you're not interested in registry activity, obviously it's better to remove that. It will make the file smaller and processing faster. And so at this point, before I actually do the full logging once again and pause the video for that, I want to still use what we have now to talk about a few things. So first, we can, as usual, we can use these filtering to focus on only certain things of interest. For example, if I'm only interested in SMSS, the session manager, which is the first user mode process that is created in the system, we can just right click here and include SMSS. We can also right click on any kind of column and just focus on something specific or remove something specific. So for instance, maybe this idea of thread create, I don't care about that. So I can right click that and say I want to exclude thread create. So it will remove all the thread create events from this log, because maybe I don't care about threads at this point. I only care about, say, processes and images. If I only care about SMSS, I can right click, and as before, I can include SMSS only. So now we see just SMSS. By the way, it could be multiple processes. You can see there are multiple processes of type of the same executable, but I've right-click the executable, not the process ID. I could also use this to include or exclude a particular process ID. And as usual, we can double-click for any one of these events and get some details, the process, in which context that happened, and the full call stack of that thing, whatever that thing may be. And if you have proper symbols configured, then you get pretty good information as to where this thing was coming from. So you can see it was coming from the SMSS executable here that called this function that then at the end of the day mapped some section here for loading that image. Now, the other thing you might be wondering is what is going on. I mean, we see here SMSS, but really, is that the first thing that actually happens? I mean, who is creating SMSS in itself? Isn't the system process the one that's responsible for creating SMSS and do some other, many other potentially initializations? I mean, how can that be the first thing? So this is where filtering comes in. If you look at this button called filter, or use the filter here, you can just click that to see the current configuration of the filter. And by default, Process Monitor tries to remove certain things that it thinks you don't care about. For example, if process name is system, this is excluded. You don't really see anything that happens when the system process is the one that is involved. And so we can remove that, either uncheck or completely remove, and try this again. And again, at this point, we won't probably see anything because of that option to drop filtered events, because they was just filtered out and we didn't get any of that. So probably the best idea is to remove that option. It's not checked by default, by the way, but it is more efficient in the sense that if you don't care about certain events, instead of them just being accumulated, they're just going to be dropped. And so you won't have to continue gathering information you might not really need. But if you do want to see everything, you have to uncheck that thing, and then you can just filter around what you see. So the same goes with other things here. There's some other things you might find interesting. You can definitely remove these checkbox here. For example, it doesn't show ProcMon activity in itself if it is running. Same goes for Process Explorer and auto runs, because it thinks it's probably not really interesting for us. But also, you can see there's some things here like operation begins with IRP MJ something. And the thing is that Process Monitor has this mode called advanced mode, or advanced output here in filter. Once you have advanced output, then you get some other kinds of events that are shown in a more, I would say, basic fashion, very close to the machine. You can see the default filters are now change completely so that you do see almost everything there is to see by default. So again, we didn't capture that, so we don't have it, so there's nothing to see at this point, but that option exists. And so once you enable advanced output, you'll be able to see some more. So to see what is actually going on and to show you a few more things in Process Monitor, I'm going to do exactly the same thing. Actually, I didn't have to close that, no need. I just need to enable, I want to remove this idea of SMSS. There's no need for me to filter on that. I just need to enable log booting again because it's being disabled automatically once you restart. So I'm going to close that and restart the system again. So in order for you not to watch me just restarting the system once again, I'm going to pause the video one more time. Okay, the system has booted. I'm launching Process Monitor again. Just like before, you can see Explorer lags a little bit. And again, we get the default operation here showing what we have filtered out. So let's just stick with that, even though we can remove that if we do want to see create thread operations. And again, we see that Process Monitor identifies the fact there's a boot logging available. We want to save that again, the same idea. Notice that the previous file was actually very small, only 5 megabytes. This one is going to be much larger. In fact, let's open this thing up and see what happens. It's somewhere in the documents. Let's see the size of this file. So this file is right now, you can see it grows because it's processing these events. So it's writing them to the file. So you can see it's growing a little bit every few seconds when Explorer is nice enough to update things. You can see again it takes some time because of the sheer amount of data that has been accumulated there. So I'm going to pause the video a little bit so you don't get too bored until this fills up. We're almost done, and now we're almost really done. And you can see the file size is already beyond 1 gigabyte. So these are common file sizes, could be even bigger than that. So now you can see that when we look at the output, we do see stuff related to the system process. We don't have that default filter that filters out these things. In fact, we can see that Process Monitor's driver itself is the first thing that actually loads here, because that's the point where it actually can start monitoring things, like the fact that the kernel is being loaded here. So it might seem weird that drivers are loaded before the kernel, but this is actually what happens with boot drivers. Boot drivers are necessary drivers, like for file system and disk and things like that, and without them the kernel can't continue doing anything, and so they actually have to be loaded before the kernel, actually loaded by the pre-boot environment, the UEFI environment, UEFI boot application, so to speak. Anyway, we can see stuff here. We can filter as before by filtering for whatever thing we want to see. For example, if all these registry stuff here, we don't care about registry in its entirety, you can just go ahead and click that button to filter out all the registry operations. And as usual, we can see what is going on just like before. We're in advanced mode, so you can see code like IRP MJ something, which is the iRequest packet major function codes. That's something you might be familiar with if you're familiar with the Windows drivers. So this gives us the actual request type instead of wrapping that in a more nice name like read or write or things like that. This is part of this idea of advanced output. So we can actually go back to the simple output to see things, well, in a simpler fashion. So it will again try to process these things to make some changes to make things look a bit easier on the eyes. So it really depends on your level of sophistication, what you actually want to see. So now you can see things like create file, things like that, and the original filter has returned. So now we see the registry process doing things, but the system process is no longer visible because now the default filter has returned with all these things that hides certain things. So you may or may not want that. Of course, once you get back into this non-advanced mode, you can definitely remove things here so that things will go back. So for example, you can say, actually, I am interested in the system process, so please bring it back. But you might still not be interested in some of these other things like related to NTFS, but in fact you might be interested in those. So you can play with that in any way you see fit. So you can see now the system process is back doing its thing, but we're not showing registry activity at this point. So again, from this point on, it's about looking at the events and looking for interesting things. Like you can search by using Control F to search for certain data, such as file names, process names, anything that that makes sense to search. You can search using that. The events are always sorted by the time, and there's no way to change that in Process Monitor. So searching is probably your best option to search for something very specific, and of course filtering is also very important. So for example, if you just care about Explorer, you can go ahead and create a new filter. So you can open this filter, you can say, okay, what am I interested in? Maybe I'm interested in something like a path. That path that, let's say, contains Explorer. Whatever that thing is, could be a process, could be a file that has Explorer in it, or some other things. So once you do that, then again the filter is going to be applied. It might take some time because there's so many events out there. You can see that at the status bar it shows you that there are actually more than 3 million events available in the log, and right now it's only showing 4,000 of them because we have a pretty aggressive filter here that shows something that has Explorer in it. You can see that Explorer here in the path column is here somewhere with the name Explorer, whatever that thing may be. And again, if once you're not happy with that, you can just disable this one or remove it altogether. And of course, the processing will happen again to build the new list of events. So now we can see the taskbar here. Sorry, in the status bar, the number of events is going to increase significantly. We should be able to see that now it's showing us more events than before. We're still filtering a lot of events, but we see 15% of events and not as little as we've seen previously. Another thing I wanted to mention, which is kind of interesting, is if you go to Tools, one of the things you can see is the process tree. And the process tree shows you, well, the process tree, which is something you may be familiar with when looking at tools such as Process Explorer. However, there's a little twist here because some of the processes have these, they seem to be like faded a little bit. You can see the icon is faded. This represents processes that are no longer alive. They were alive at some point, but then they were destroyed as part of the boot process. You can see here the lifetime. So they have a finite lifetime here. They're not alive right now. Once the boot sequence has ended, they're not alive anymore. This one was alive very short period of time. Here's another one that was alive very short period of time, and so on. And so all these faded processes indicate processes that are no longer alive at the end of the boot. And you can see some details about these processes that are shown here, and also at the bottom once you select one process or another. If you only want to see these processes that are currently alive, you can check this box here, and that will filter the tree again just to the processes that remained alive at the point of the end of the capturing of event for the boot stuff. So just see process that survive. For example, well, not quite apparently. There's another SMSS here which is shown as dead. It really shouldn't be shown here, but in fact it has to, because CSRSS, being its child, must be it's still alive, and so it has no choice but to show its parent here. Otherwise CSRSS will not be able to be shown at all. But it's trying to only show us live process unless there's one of these cases where the parent has died and the child has remained alive. In fact, this is something that you might be familiar with Windows SMSS. There's only one when you look at a normal Windows system, but in fact the way sessions start is by SMSS launching a copy of itself into the new session, and that copy creates CSRSS and WinInit for session 0 and CSRSS and WinLogon for session 1. And here's another SMSS which is no longer alive. It created CSRSS and WinLogon. This is for session 1. That is the first interactive user session. So it's shown here, and that's just because there's no other way. Otherwise these two will have to be hidden as well. So there's only one SMSS that remains alive, but there actually exists one temporarily to initiate or to initialize a particular session. In this case, it goes with session 0, which is always there, and session 1, which is the session that was created for me as the first logged on user. So this thing could also be interesting to see exactly what happened in terms of processes, and it's definitely interesting to see which processes existed earlier, even though they don't exist right now. It's interesting to see what was running at various points in time as Windows was booting up. So everything is here, and you can look at all this information right there. There are other things you can do with Process Monitor. Again, this is beyond the scope of this video, but in general, if you want to see what happens when Windows boots up, this is a great way to get a lot of useful information to research, to find, to look for things that are happening when Windows boots up.